Welcome. So let's get started. So now we will cover combining functions, shifting, and scaling the graphs. So the following are the learning objectives. First, we discuss about the various algebraic manipulations on functions, how they affect the domain, etc. Taking the composite of two functions or more. What does it mean to shift the graph, right? How it reflects in the function itself, scaling, reflecting the graph, etc. Okay, so let me start with algebraic manipulation. Okay, so what do I mean by algebraic manipulation? So I simply mean adding two functions, subtracting two functions, multiplying two functions, and dividing two functions, right? So what does it mean? So if you add two functions, what happens? Well, you get a new function. Right? So let's say that you have a function y is equal to f of x, and let's say that you have another function uh, y is equal to g of x, right? And here, let's say that your right. So for simplicity, let's call it d of f. So this is the domain of f, and similarly, d of g stands for the domain of g, etc. Okay. So what does it mean? So if you add, so adding, if you add two functions, so let's call it h of x. This is f plus g of x. So this is a new function. But what does it mean? It simply means adding element wise, right? So you compute f of x, you compute g of x, you add. So that's it. But then this is a new function. This h is a new function. But what is the domain of this h? Well, it's the uh, intersection of the domains, right? Because to be able to compute f of x, you need to know that x it's x is valid, right? It's in domain of f, and to be able to compute g of x, you need to know that x must be in the domain of g. So x must be both in the domain of f and g. So it must be in their intersection, right? So if this is your domain of f, and if this is your domain of g, then this intersection is going to be your d of h, right? And it's the same for subtraction. So if you want to subtract, right? If you want to subtract the two functions, it just means f of x minus g of x. So again, the domain is also the similar, so its intersection. And similarly, if you multiply two functions, it becomes a new function. Again, it's element-wise of multiplication. And if you want to divide two functions, f to g, then it means compute f of x divide by g of x. But here, provided you cannot have g of x equal to 0, right? It must be not 0. Okay, so if you really want the example, I mean, okay, I can give a quick example. So we can take f of x to be like x squared. I don't know, g of x to be, if you like, x plus 4, maybe. So then, what is f plus g x? Well, it's you add x squared, x, so it's simply x squared plus x plus 4, right? Let's do like f times g of x. What is it? Well, this is x squared multiplied by x plus 4, and so on, so forth, right? It's more or less clear. Right. Let's move on to the composite functions now. Again, if you have two functions, you want to take their composite, then it becomes a new function. So here's the definition of composite of two functions. So it's represented by this little circle, f composite with g, or we also sometimes call it fog. So what is this? So here's definition. So f of g of x, or f composite with g, is equal to f of g of x. Okay. So what is the domain here? The domain consists of all numbers x in the domain of G, for which g of x lies in the domain of f. So what are we really doing here? So let me illustrate. Let me illustrate with a graph. So let's say that I have a function g, right? Here's my function g. Here's my g. What it does is it takes one x here, right? Maps to a y, to some point here, y, right? So this y is, what is this y? Y is my g of x, right? And let's say that I have a function f that maps this particular point y, right? This point into another point, like this. Let's call this z. So what is z? Z is, this is my f of y, right? So instead of going from x to y and then from y to z, let's say that I want to go directly from my x to this point z. So that's my f of g function. So this is my z. Why is that? Well, let's look at the definition, right? What is my f of g of x? What is it? Well, this is, by definition, it's f of g of x. But what is my g of x? Here's my g of x, right? G of x. So this is equal to f of y, right? But what is my f of y? F of y is equal to z. So this is equal to z, right? So that's what I get. So first so to compute f of g of x, you first need to compute g of x. This is the first. And then you compute f of g of x, okay? So let's do example. So let's take my f of x to be, I don't know, let's say x squared. My g of x, uh, let's take it to be square root of x plus 1. Okay? So first, let's try to compute. First, let's try to compute f of g, fog of x. What is this? Well, by definition, this is f of g of x, which is f of, what is g of x? Well, it's square root of x plus 1. But what my f does, it squares everything. So I need to square it here, right? I need to square this x plus 1. So it becomes simply x plus 1. So my fog is just x plus 1. However, we need to be a bit careful here. What is my domain here? Well, what is the domain for g here? What is the domain for g? Well, inside of the square root cannot allow negative values, so which means my domain must be from -1, right? From -1 to infinite. So that's it. But then for f, I don't have any restriction. X squared is perfectly fine. So that's also becomes the domain of. So that becomes the domain of this fog. So in this case, so the domain of this composite is the same as the domain of. Okay, so let's do one more. Let's do g of f of x. What is this? G of f of x. What is f of x? F of x is x squared. So it's x squared. And then what does g do? What g does is it takes the square root of x plus 1. So in place of x, now I have x squared. So I need to have square root of x squared plus 1. So that's my new function. right? And it's you can easily see that here the domain of this jof is everything, right? It's all R. Okay, let's do one more, just fun. Let's try, for example, g of g x. So this is g of x. Well, this is g of square root of x plus 1. But then, what is this? In place of x, I need to replace by square root of x plus 1. So this is square root of x plus 1 plus 1, right? And it's you can determine. So I leave it an exercise to determine the domain. So what is the domain? Okay, just think about it. Let's do one more. So f of so this is what is f of x? It's x squared. So it's the square of x squared. It's x to the square of square. So this is x4, right? I mean, here it's not difficult to see that the domain is all of R. Okay, so then our next objective, shifting the graph of a function, right? So let's say that you have some graph. You want to shift it to the left or shift it to the right, or you want to shift up or shift down. And how does this uh, can be seen in the function? So here's the effects, right? So vertical shift. You have a function f of x. If you add some constant k, then if the constant k is sort of positive, then this means you are moving the graph to the above, up. If it's negative, then it means you're moving the graph down by k units, okay? And what horizontal shift, so here you need to be a little careful. So you see horizontal shift is here I compute f of x and then I add some value. But here I do not compute f of x. First I compute x plus h and then I take the f, right? So then it becomes horizontal shift. And again, here, if h is positive, you're shifting left. You see, positive shifts left, not to the right. And if your h is negative, then it means you're shifting right by opposite value h units. So let me illustrate with the example. So for simplicity, I will take my f of x to be x squared, my parabola, right? Remember the parabola? Here is the parabola. Okay, now let's look at the function h of x is equal to f of x plus, sorry, f of x plus 2. You remember? What does this do? It does vertical shift, right? So it moves entire graph 2 units, right? So here, it started here, the bottom here is 0, so now it means I need to move it by 2 units. So my graph becomes, it's the same graph, I'm not squeezing or I'm not shrinking, I'm not stretching, right? It's the same graph, except it just moved 2 units up. If it was negative, then it would be moving down, right? Uh, yeah. How about one more? Maybe we can also do this. Okay, f of x, let's say -3, right? So it means I need to move the graph by 3 units, so below, right? So here's -3. So my parabola looks something like this. Okay, how about if I look at h of x to be f of x, oh, sorry, of x plus 2 plus 2. Remember? So first I need to compute x plus 2 and then assign f, right? Evaluate that f. So it means this is horizontal shift. Plus means shifting left. So I have the same original graph. I need to shift 2 units, right? So it needs to start somewhere here. So that's how the graph looks like. And one more. Let's do f of x minus 3. So this is going to shift to the right? So let me split like this. So avoid the confusion. So I need to move 3 units, entire graph, something like this. Okay. Okay. Now, what are the other types of manipulations to functions? Well, let's discuss scaling and reflecting the graph of a function. So here's the summary. If you have a constant c larger than 1, and if you consider new function, so you have c times f of x, that is going to stretch the graph of a vertically by a factor of c. Okay. If you divide the function by c, then it's going to compress vertically. If your c appears in multiplies by x, and then you take the f, then this is going to be compressing. But if you divide, it's going to be stretching. Okay, and this c is equal to -1 is something special. It makes y equal to minus f of x, reflects the graph of f across x-axis, and if this minus is inside, it affects the x directly, then it reflects the graph across the y-axis. So let's do some examples. Again, let me simply take my y is equal to x squared, my parabola. And what happens if I multiply parabola by, so what do I want? Okay, let's do stretching, right? So what happens if I consider the following function: f of x is equal to 2 times x squared, right? So if you go back to so what's happening? So I'm doing this, right? So here's what I'm doing. So it means it's going to compress the graph. So multiply, compress the graph by a factor. So original. So what was my original graph? My original graph was something like this, right? This was my y is equal to x squared. And then my new graph, let's also call it y is equal to, but now it's going to y equal to 2x squared, right? Or if you like 4x squared. So 2x squared. So it's going to compress, right? So it's become sort of narrower, okay? It becomes narrower. So what would happen if you do divide by, right? So what happens? Let's do g of x divided by 2 squared. So this make so this is the situation. So y is equal to x over c and then f. So it's going to stretch, right? Not compress, it's going to stretch the graph. So it becomes wider, right? The graph becomes sort of wider. It becomes much wider, something like that. Okay, so this is my y is equal to g. Okay, how about this vertical manipulations? Let me do a slightly different example. So let's consider f of x is equal to, well, let's simply do like x, right? So what is it? What is the original graph? So this is my original graph, right? Y is equal to x, if you like. Now what happens? Yeah, okay, but anyway, this will make, anyway, so what happens? Let's multiply. Let me look at Oh, maybe I can see the screenshot here also, but right. So if I want to make, if I do like y is equal to 2x, what happens? So let's go back here. I'm doing this, right? 2x. So it's going to stretch the graph of f vertically by a factor of c. So my graph, you see, original is here it's like 45 degree, right? It's 45 degree. Here it's also 45 degree. But now this becomes stretched, so it becomes larger, right? Something like this. Okay. Let me pick a different color. If I were to do y is equal to x over 2, so what does it mean? It means it compresses vertically. So you will get compressed, right? So something like this. And original is right in between. So original is here, 45 degree. Okay, so this is how you sort of read what's happening to the functions.